All right, so first thing we're going to look at is difference of squares. So difference means it's a minus in between, and squares means that both of our numbers are perfect squares. So if they are, then a statement like this, we would take the square root of each number, which in this case, square root of a squared is just a, square root of b squared is just b, and then one is a plus and one is a minus. So basically all you need to know in order to factor is just that statement that we take this and make one a plus and a minus, but I want to take a minute and show you why that works as well. So here we would FOIL this back out. Sorry, my markers don't want to stay put. Here I would take a times a, which would give me a squared. Here I would take a times negative b, which would give me minus ab. Here I'd take b times a, which would give me plus ab. And here I have b times b, which would give me minus b squared. So what happens with that is the plus ab and minus ab cancel and get me back to here. So that's why we're able to factor it this way. If they were both pluses, it wouldn't work because they wouldn't cancel. If they were both minuses, it wouldn't work because they wouldn't cancel. All right, which brings us to our next one. Here, and actually I'm going to do this in pencil and I'll explain why here in a second. A lot of times I see students who want to factor this into a plus b times a plus b, and that actually doesn't work. I'm going to take a minute and show you why here. If I do, again, if I FOIL this back out, I would get a times a, which is a squared, a times b, which is ab. Same thing here, ab, and then b times b, which is b squared. Up here, the reason this worked is because one was a plus and one was a minus, so they canceled out and left me without a middle term. That would not happen here. When I add those two together, I would get 2ab. So I would end up with a middle term here, which doesn't show up in my original problem. So difference of squares does factor. If we've got sum of squares, it does not. So this does not factor. All right. Our next one is sum of cubes. So even though with squares it doesn't work, the sum of cubes works a little bit differently. So just like up here where we took the square root, if it's cubes, we're going to take the cube root. So in my first set of parentheses goes the a and the b, and I'll come back and fill in the signs here in a minute. And then we take our first one squared, which in this case is a, so it would be a squared. Then we multiply them together, which would be ab. And then we take our last one squared. So that's the setup for sum of cubes. It's also going to be the setup for our difference of cubes. The other thing that helps me remember the signs here is the word SOAP. So if you're thinking of sum of cubes, difference of cubes, think of the word SOAP. This gives us our signs. So S stands for same. So if it was positive here, it stays positive here. O stands for opposite, so if it's positive here, it's negative here. And then the AP stands for always positive. So it's same sign, opposite sign, always positive. So this is our formula for how we factor sum of cubes. And again, I'm going to take a minute. This is the only part you'll actually need to do the problems, but to explain why that works. Again, we would distribute this out to get back here. So a times a squared would give me a cubed. When I multiply these, I would have a times a, which would give me a squared, and I have the b that goes with it. Here I would have a times b squared, and it's positive if I multiply these. If I distribute the b, I would get plus an a squared times b. Here I would get minus a times b squared, and here I would get my plus b cubed. So if we look back here, I have a minus a squared b and a plus a squared b, so those cancel out. Here I have an ab squared and a minus ab squared, so those cancel out, and I'm back to my a cubed plus b cubed. So that's why this works. Again, I'm not as concerned about you memorizing all of this. You'll talk more about that in Algebra 2, but this is the formula that works when we have to factor something that looks like this. So very similarly for our difference of cubes, we're following the same process. So we take the cube root of each, which in this case is just a and b, and then squared, multiplied together, and then second one squared. Same signs. or I'm sorry, same process for signs here, so we still use that SOAP. So same would be minus, opposite would be plus, the last one is always positive. So same, opposite, always positive. And again, if I multiplied it out, I'm not going to take the time to do that again, but if I multiplied it out similarly to the way things canceled here, they would do the same thing here and leave me with my a cubed, b cubed. So when you're starting your activity, these are the formulas you're going to want. So if you haven't been writing them down, you might want to pause the video right now, go grab a piece of paper. These are the formulas and the things that you're going to need to know to do the problems that you're going to see on your activity. For our first one, I see a cubed, and this is also a number it's a perfect cube. I know we're not in the classroom, but they were those numbers that were hanging up above the windows in my room. So what I'm looking at is what's being cubed here. So in this case, this is x that's being cubed. Then I need to figure out what number is being cubed that gets me to 8. So I could do the cube root in the calculator if I didn't know it off the top of my head. But in this case, I know that 2 times 2 times 2 gives me 8. So I know that 2 cubed is what's getting me to the 8. So I'm going back to my formulas that I had talked about. So this is a sum of cubes problem. So I take the cube root of each one. So this is x and 2. And then I do first one squared, the two of them multiplied together, the last one squared. And then I use SOAP for the sign. So since this is a plus, the same would be a plus, opposite would be minus, and my last one's always positive. So this would factor into that. Okay, my next one is a squared. So I'm looking for difference of squares here. It is a minus, so that's a good sign. Next thing I have to check is that my numbers are perfect squares. So if I take the square root of 121, I get 11. And the square root of x squared would be 11. Would be x. Square root of 49 is 7. So these are perfect squares, which tells me I can factor it using difference of squares. So it just means I take the square roots of each one. That's what goes in my parentheses, and then one's plus and one's minus, which gives me the negative I want here, and also makes that middle term cancel out. So that's what that would factor into. Okay, my next one, I see I'm back to cubes, so I would check the cube root of these numbers and make sure they come out to perfect cubes, which in this case they do. Cube root of 27 is 3, so this is 3a that's being cubed. Cube root of 81 is not a nice number. I made a mistake. So you can't do this. If this were your problem, you would simply say this doesn't factor, but I made a mistake. I wanted this to factor, so I'm going to change that number. What am I going to change that number to? I'm going to change it to 125. So hang with me here. So in this case, it would factor. It would be, if I take the cube root of 125, I get 5. So again, my original problem would be a does not factor, but I changed it so that it will, just so I can show you another example of what that looks like. So here, I'm taking my two numbers. Those are what go in my first set of parentheses. And then I take this one squared, so that would give me 9a squared. I multiply these two together, which would give me 15a. And then I take my last one squared, which, I'm running out of room, but I'm going to put it down here, would be 25. Again, I go back with the SOAP for my signs. So I look here, this was a minus, so the first one is the same. The next one is opposite. The last one is always positive. So that's what that's what this would factor into. All right, for my last example here, I'm back to squares, so I'm looking at difference of squares, and here I don't have a difference, so I can stop right there. So anytime I have a squared and this is a plus, I know it doesn't factor. Another giveaway to me that this doesn't factor is that 5 is not a perfect square, so that number has to be a perfect square. So be aware, there are going to be some out there that do not factor. Don't be alarmed if you run into those. We're just going to simply put that it does not factor.